All right, so we've got the first question. They're all from exams, these questions that we do. So just be careful with this. You should read this. It's showing that it's going to be in the next couple of questions, so we need to remember that. So Laura invests $25,000 at an interest rate of 8.1% per annum, compounding monthly. So we've learnt a few things. This is like VO or principal, PV. This is the I in our thing, and the or R when we're talking about our formulas, and PPY is 12. And at the end of each month, she after interest is calculated, so they're always going to say that, she withdraws 400. So she's going to take out a payment. And if we're talking about finance solver, she's getting that, so it's a positive payment. And this is an investment, so PV is going to be negative. Just remember for that. So it says, which of the following recurrence relations could be used to determine the amount? So we know with a recurrence relation, we always have to have VO. So we've already got 25,000. So look, you can quickly look down. So I'm looking down, but they all have 25,000. So that doesn't eliminate any questions for me. So next one, it's so now we need to work out the rule. So the VN plus 1 rule. Now, when you have an investment, or you always have the R, so you're gaining money. So R will be a number bigger than 1. So bigger than 1. And if you remember, we find that by going the rate over PPY over 100, 1 plus that. And that's how we're going to do it. And then we'll have VN, you times the one before, and then it will always have your payment. Now, she's taking this out, so it's actually in the recurrence formula, she's minusing 400. Sorry, I don't know why I wrote 500. So 400. So you could quickly look through, and I don't know, is there any answers? They're all 1 something, so we're going to have to work out the R. So I'm going to go into R. I'm going to do 1 plus the rate, which is 1.8 over 12 over 100, and I'll find out what that R is, and I'll do that on the calc. We get 1.0015, and that's only this answer. So that one is. So we have to be careful. They do want the monthly formula, but they are going to match up here anyway. All right, all good. This next question is still using what we did before, because it said question 19 and 20. So the value of Laura's investment after 12 months is, now this one, we probably would use finance solver for it, because we don't normally use the nth term when we have a recurrence formula that has the extra payments in. So because we see this 0015, but it's VN, minus the payment, which was 400. We don't do the nth term for those ones, so we probably want to use finance solver here. So N is 12 months, which is actually 12, because it's 1 times 12, because it's monthly. Interest rate was 1.8. PV, because it's an investment, was negative 25,000. Payment, so she was getting those payments. So for finance solver, it's actually a positive number. FV is the question. So the value, final value at that time is the question. So PPY is 12. So if I'll pause that and put it into the, okay, so we get 20613.9. So we're going to say closest to E is the answer. Okay, question 21. Sarah takes out a reducing balance home loan. So if you go to your formula sheet, we do have that, a reducing balance loan. Okay, the interest rate of 3.8% per annum, compounding annually. So there's I, PPY sorry, is 12 monthly. I think I said annually then. The loan is to be repaid with monthly payments. So here's the payments, and they would be negative on a finance solver. And the 3 lines of the amortization table 101 to 103 are shown below. So Sarah is able to make a larger payment at the 102 month. The amount of 102 payment is closest to. So they've flagged up that this is not going to be the normal payment, and this is actually the question. So she's actually able to make a larger payment. So you know the number should be larger. So first of all, we need to work out a few things. We know from a reducing balance loan that the payment minus the interest would equal this what it actually reduces by. Because remember, you have this home loan or whatever, you get charged interest, your payment has to pay that interest first, and then whatever's left of your payment is used to find what the loan will drop by. So I'm going to work out this box, or how much it dropped by using the other. Because what actually happened, this was found by using, so say the principal reduction, it was actually, to find that, I could do the balance before minus the current balance. So what do I mean by that? I mean this one, so the 266,758.78 minus the one it actually is, to see what it actually dropped by when she did this extra payment. So let's do that on the calc. Okay, so I end up with, this is how much the principal reduction was. So I've got this 1514.26. Okay, so I've got that, but I probably also need to find this interest in here. Now the interest, so if we go in and find how much interest was, remember interest amount equals the rate over the PPY over 100 times balance before. Now they've given me the rate in the question, so I've got 3.8 and I've got the PPY, so I don't have to go find the interest rate. It's not that hard. And the balance before is up here, so 226,758.78. So I'm going to find the amount of interest, so we'll do that on our. So we get the interest to be 844.74, I'm going to say. Now, just so you can check that, this interest should be getting less, and it has. So I'm happy with that number is correct, that it was 844.74. So now to find out what the repayment, that repayment must have been, if it must have been the principal reduction minus what interest. So we, it would have been, the payment would have been, the principal reduction would have been the payment minus the interest. So if we get the principal reduction and add the payment, .74, we're going to find out the big repayment. All right, so we get answer C, sorry. Okay, so I put that one in wrong in the calculator. So that was actually, here was 414.26, and this was, but that answer should be right. Yep. Okay, question 23. Miriam invests 25,000 into an account that earns an interest rate of 3.2% compounding monthly. So she's invested, so that's a negative PV. They just gave me the I. and they gave me the PPY is 12. Each month after interest has been calculated, Miriam withdraws a fixed amount of money. After 2.5 years, so because this is monthly, it would be 2 times 12 plus 6. So we've got 30 months. The account balance, the balance of the account is this. So we know that this is FV at that time, okay? The amount that Miriam withdraws each month, so payment has become the question. So if we go and do finance solver, we know N is 30, I is 3.2, PV is negative 25,000. Remember that she invested. The payment, we pop that's the question. FV at that time is positive 6475 because it's an investment, so it's her money coming back to her, and PPY is 12. So if we pop that into the finance solver, we will get a payment of, it'll say, because she's going to get this amount, so it'll be a negative 339.997, but she's actually taking that out, so we're going to say closest to C 340. Okay, question 24. If Eddie borrows 150,000 at 5.6 per, so he's borrowing, so we just start to make sure that's a PV positive at 5.6 per annum. So they've just told me the I, and compounding monthly PPY is 12. To be repaid over 25 years with monthly repayments. After 3 years, the interest rate rises to 6.1% per annum. In order to pay off the loan in 25 years, Eddie's repayments must be. So first of all, we need to, this is like a change in scenario, and we need to get to the 3 years scenario first. So let's go back to what we've originally got, and we want to know, and they want to know something about their repayments. So I need to get the original, what's his original repayments? Because if we have a look, if I write out everything that we need to do in Finance Solver, and FV and PPY is 12. So I know that's 12. I know the interest rate is 5.6, and I know he, at the start, he invested, borrowed 150,000. So we want to know what his monthly payments are originally. So what we're going to say, it would have been the 25 years that he would have zeroed it off. So I'm going to get this, the original payment. So this is going to be, this is the original scenario. All right, so I do that and I get the original payment of, if I pop that in, I get the original payment of 930.11. So now I know what the original payment is, but after 3 years, things start to change. So, and it increases. So remember when I said, when you have a change in scenario, we're going to pretend that we're starting again. So to start again, we need to know what's owing at 3 years, after 3 years. So first I'll do that. So to know what's owing after 3 years, I'm going to do 3 times 12. The interest rate at the start was still 5.6, and PV was still, he got 150,000. The payments we now know, they're negative 930.11, and the FE is what I want to know, and PPY is 12. So we pop that in and we get a final value of 1,4,1,002.29. So he's still owing, that'll be a negative too. He was still owing that much. So now we're going to pretend we want to, in order to pay it off, the loan, because it now increased. So now we're increasing the interest rate, increase I to 6.1%. But we want to know what the payments are once this new scenario, but he's still going to pay it off in 25 years. So we've already done 3 years. So 3 years out of the 25 means we've got 22 left. The interest rate's now gone 6.1% because I've got to try and find the payment change. So PV is now going to be what's owing at 3 years, because we're going to say that's our new thing. So he's going to, it's like he's borrowing that much. The payment is the question. FE, he still wants to zero it off after that, and PPY is still 12. So in the end, we get a payment, once it increases, his payment is now negative 971.50. So therefore, the change in payment, he's now at 971.50, but was originally only paying 930.11. So it increased by 41.39. So that's E. Okay, so the Yarra Grove Wool Factory has 48,000 balls of wool to ship out to surrounding retailers each week. The number of balls of wool remaining at the factory after N weeks can be modelled by this recurrence relation. The recursion can be used to calculate the number of balls of wool remaining at the factory after 2 weeks. Complete the calculations by writing in the appropriate thing. So it's always going to be, you do 48,000, and here up here we can see that 3,500 get minused every time, and that brings that to that. So when we're doing the next recursion, it'll be the one before, which is 44500, and it will be minus the 3,500, and then you just simply do that calculation, which is 41,000. So how many balls of wool ship out each week? So they're just asking you to pretty much read the formula. So that was easy, 3,500. And the last question, the number of balls remaining in the factory after N weeks can be determined using the rule. So we want the nth rule. So, and this is it's like a flat rate reduction. So if I go to our formula sheet and I'll find your flat rate, hold on a sec. Okay, so this is like the flat rate. And if you see, we have a recurrence relation that looks like this, the Vn, or Bn in this case, minus the D. So when we want to, this here is the net nth rule column. So when we want to write the nth rule, we do VO minus n times D. So you can see there's the times n. So D from our original formula is 3,500, and our VO is 48,000. So we can just do it like that. Okay, the factory continues to ship out the balls of wool at the same rate. How many weeks does the balls of wool remaining at the factory first become less than 15,000? So you have an nth term formula. So if you look in the question before, we've got Bn equaled 48,000 minus 3,000 times n. So they're giving you a value there. So we want, when does it equal that? So we want to know, when does it become that? So we can pop this, write it out like that, and n's going to be our question. So we can do solve, comma n, and you get n to equal 9.28, so on. So if it's it'll become this in the night. It's not quite there when it's 9.28. So you're not there. You'd have to say it would be less than that, and you'd have to say the 10th week. So therefore we'd say after the 10th week, we are less than. So you always got it when it's predicting things like that. You got to go into the next week. It doesn't matter if it's 9.1, 9.2. It's just got to be the next week. So after the 10th week. All right. Okay.